Welcome back, class. Today we're going to be doing approximations and errors. Continue on with the chapter. We're going to be doing 1.B approximations today. After today's lesson, you should learn how to, or know how to, estimate products using approximation, estimate quotients, division using approximations, and estimating some real-life measurements. So, let us begin. We're going to start with some approximations. Remember, when I point there, just yell out your answer. Approximation is a blank way, a fast way of blank. A calculation is performed in one figure approximation. A fast way of blank a calculation, of estimating a calculation to perform a one figure approximation. So what this means is you're going to have to do a couple things. Number one, you're going to have to leave the single digit numbers as they are. So if you only have a digit with one number, it stays the one digit. You don't have to estimate it. Round all the other numbers to one significant digit. All right, one over significant digits before, that is just one significant digit. And then you're going to perform the calculation. So let's look on how to do this. So when we're going to estimate 872 times 52. Think back to when we were doing the building heights. One significant figure here is which? The 8, right? So since we have the 7 there, we're going to round the 7. It's higher than 5, so that rounds up to 900. And 2 is less than 5, so this rounds to 50. Notice I round this one to the hundredths place and this one to the tens place. It doesn't matter what place you round it to. What matters is the significant digit you're rounding it to. So 900 times 50, very simple, is 45,000. And that's it. So why don't you attempt problem B? You attempted it, let's go see what you got. So we're going to the one significant figure, which is the 6, less than 5, so this rounds to 60,000. 3, greater than 5, this rounds to 400. 60,000 divided by 400, well, I can go, if you really want to be fancy, you can go, oh, chop this off, chop this off, chop this off, this off. 600 divided by 4, you can do that in your head, that's about 150. Is that the exact answer? No, but it's a good estimate. Good, you finished it. So into this one, 4 is our significant figure, 3 is less than 5, so it rounds to 4, 0.4, because it's the first non-zero number, 8 is greater than 5, so this rounds up to a 5. So you got 4 times 5 tenths, or 4 times a half. Half of 4 is 2. And this means approximately. All right, see? Ready to do a bunch of examples? Now, your turn to show me what you got. Let's go. I want you to do all these problems. Do you know how many there are? How do you estimate? 3 times 5, 15 problems. All right, so you should have done them all. I am just going to go through them as if you did them all already. Ready? First one, this rounds to 30, 6 stays 6, because it's one digit number, it stays the one digit. You don't round it to 10. 30 times 6 is 180. 60, the 7 stays 7 because it's one digit. 60 times 7, 420. 80, 3, the 0 is obviously less than 5, so it stays 30. 80 times 30 is 8 times 3 is 24, and then you got 2 zeros, 2,400. All right. 200, the 3 stays a 3. 600. So you can do these in your head. 500, this stays 50. 25,000 is 25,000. This is like the easiest lesson ever. 6,000 times 4. 24 and 3 zeros is 24,000. 48 rounds to 50. 23 rounds to 20. 5 times 0, 0, 0, 1,000. 60 times 40, 2,400. 150 is 5,000. Right? This one right here, 3,000 times 20. 60,000. 400 300. 12,000,000 is 120,000. Right? 8 makes this go to 4, 4,000. 7 makes this go to 330. 4,000 times 30 is 12. 4 zeros is 120,000. Right? 2.7 rounds to 3. 1.15 rounds to 1. 3 times 1, that's a tough one, that's 3. 5.36 rounds to 5. 0.6 rounds to 0.7. 0.68, not significant. This is the significant one. 5 times 0.7 is a 3.5. Got it? Awesome. All right, this one. 2, 8 rounds this to a 30. 1 rounds this to a 6, stays 6. So 30 times 6 is 180. Hopefully you got all those correct answers. Ready to do some more? Of course you are. Do the next. 3 times 4 is 12 problems. Now we're going to do division. That was multiplication. Now it's time for division. Ready for division? Awesome. Round. 90. 3 is a single digit, so it stays 3. 90 divided by 3. 9 divided by 3 is 3, 0, 30. See? Now you can do math in your brain with no calculators. 60 divided by 5, 12. 500, 20. If you want to chop off a 0, like I said before, 0, 0, 50 divided by 2 is 25. 600 divided by 40. 60 divided by 4, 15. 4,000 divided by 20. 4 divided by 2. Look what we're doing. Chop off the zeros. Make it easy. 400 divided by 2, 200. Do you have to do this step? No. Is it easier to do that step? For me it is. 80,000 divided by 80. Take a 0 off. 8,000 divided by 8. That's 1,000. See? You ever think you can do math like this in your head? I say that a bunch, I think. 300 divided by 60. 30 divided by 6, 5. 7 rounds up, 50,000. 9 rounds this to a 2. And 50,000 divided by 200. Take off 2 2s, 2 zeros, take off 2 zeros. 500 divided by 2 is 250. 0.62. 0.6. Keep the 3. If you want, you can add a 0. Move the decimal place once here, get 6. Move the decimal place right here, get 30. 6 divided by 30, 6 over 30. Might not help you at all, but you should get 0.2 as an answer. I don't know if going the opposite way helps you. 46. Nope. The 6 rounds this to a 50. Divided by 5. 10. 600. 30 makes it 600. 0.29 becomes 0.3. Final answer is, if you want to move the decimal place over to get rid of decimals because you don't like decimals, 6,000 divided by 3 is 2,000. This is like we used to take the PSATs with no calculator. $20. 4. Answer is 5. Notice most numbers become whole numbers. Nice and easy. Right? Now, going over a practice IB exam, because I didn't take a class for this class, I noticed a lot of the messing up that students do is with rounding and is with significant figures. 3 significant figures at all times, unless they say to round to approximate, then you got to make sure you round it to the right thing. Go do the problem 3. Now we're going to turn this into word problems. Estimate using one figure approximation the cost of blah blah blah. All right, you did the problem. 8 kilograms of apples at €2 and 2 euros and 2.80 euros. I don't know per kilogram. I don't know what a cent is in euros. So you would just simply get 8 times 3, single digit. 8 rounds it up to a 3, and that would be 24 euros. Obviously, it'd be less, but it's an estimate. 3 airline tickets at $213 each. So, well, first off, what do? Multiply or divide? You multiply. 3 stays 3. 213 is about $200. 600 bucks. $600, sorry. 7 theater tickets at $87.30 each. 87.30 is about 90. 7 times 90 is $630. All right. 55 liters of fuel at, oh, I forget what the L like that is. Correct me. I feel bad. Ever since they went to the euro, everything got messed up a bit. 149 per liter. What do you do? Multiply again, 55, rounds up to 60, 5 makes this 6, 60 times 1, 4 right here. We don't round, double round. We don't make this 5 and then round to 5. We just use this 4. Round this down to 1. 60 to 1 is 60 L's. I have to look that up for next lesson. Alright, number 4, approximate using one figure approximation. If this is multiplication, what do you think this is? Come on, deduce. Alright, find the distance traveled if Brody drives 4.2 hours at 63 kilometers per hour. Hour to the negative 1 is the same as putting kilometers over the hours. So, is it division? No, it's actually multiplication. 4.2 rounds to 4, 63 rounds to 60. 4 times 60 is 240. 240 kilometers. Hours over hours cancels out. Number of days in 14 years. How many days is there in a year? 365. Now you can say every 4 years is 366, but we're estimating anyway. And when we estimate 14, we estimate that to be 10. And 365 or 366, both round to 400. So 10 times 400 is about 4,000 days. All right, so the leap year, that argument doesn't hold up. Average weight carried per truck if 400, they spell tons differently overseas. 423 tons of cargo is divided equally between 18 trucks. All right, so now, what do you think you're doing? Are you still multiplying? Dividing. 423 rounds to 400, 18 rounds to 20. 400 divided by 20. You take the zeros off, you get 40 divided by 2, and you get 20 tons. Total pay for part-time worker who works on average 18.2 hours per week for 12 weeks, and he earns 21.5 euros per hour. 18 rounds of 20, 21 rounds of 20, so you got 20 times 12 week rounds of 10. 20 times 10 times 20, 2 times 1 times 2 is 4, and 3 zeros is 4,000 euros. That's like a triple estimation. Bam. All right. Good. Let's go through some more examples. You want discussion first? We're going to probably discuss this, but I'm going to read this to you anyway. Suppose there are 18 biscuits in a packet. You like biscuits? Do you know what a biscuit is? Look it up. That's like an English, European thing too. And 32 packets are packed in a carton. Using one figure approximation, how can we estimate 20 times 30 is 600 biscuits in the carton? This is close to the actual number of 608 biscuits. So, will one figure approximation always be this close to the exact value? What do you think? No. What is it about these particular numbers that makes this estimate so close? So what do you think is about it? Say something. All right, let's see. What is the actual numbers are very close. This is only 1 off, this is only 2 off to the estimates. Also, this number is a little less than the estimate. This number is a little bit more than the estimate. So that's what makes the actual answer pretty good. By comparison, you might consider that 24 packets, each containing 14 biscuits. Now, if you did 24 times 14 and found the exact answer, and then you wanted to do 20 times 10, well, 20 times 14 is 336, but if you estimate it, you would only get 200. Why is that? Well, this one is 4 above, but then you still have to round down. This one's also 4 above, and you still have to round down. So it's the farthest it can be away from the estimation, and they're both going in the same difference, right? So this difference even though this is the same type of estimation type thing, so big, because the actual numbers are not close to the estimates, and because both numbers are rounded down. When you round one up and down, it's a lot closer. Good? Awesome. All right, activity 1. Oh, we're done with our lesson. Now, an estimation is a value that has been found by judgment or prediction instead of carrying out more accurate measurement. We often estimate when it is blank for us to measure. What do you think? When it is difficult for us to measure. Whenever we do this, it's important to round the numbers to a sensible accuracy. In order to make reasonable estimations, we often appeal to our previous experience. Now, what we would typically do now in class is we work in pairs, and we estimate like the height of the ceiling, the height of the door, the height of the building, stuff like that. We're not here right now, so maybe when we get back in the class, we can do a fun activity like that, and then we see how it compares to the actual answers. But for now, this completes our lesson. This is all we had to do today. What's this easy lesson? Don't you love approximations? I do. You know why? Because it's nice and easy, and now you know how to do it. Just remember, this is just one figure approximations. You can always do it to different things depending on what they're asking for. In this case, we're good. All right, so till our next lesson, it was great teaching you guys.